7.5 properties of trapezoids and kites. A couple more types of quadrilaterals for us today. So your essential question: what are the properties of trapezoids and kites? I have that you can use pages 398 to 400 to help identify properties of trapezoids. So you're going to want to read through that at some point. You can also pause the video right now and go look it up and see if you can fill in these blanks, and then come back and watch the video and see if you got them right. That's a good way to kind of quiz yourself on your reading comprehension. So a trapezoid has exactly one pair of parallel sides. Okay, so down here, I say draw a trapezoid below. So I'm going to go ahead and show you what I mean as I do these, okay? All right, so one pair of parallel sides, we usually call those the bases. I'm going to try and make these not look the same, so maybe something like that. So we have one pair of parallel sides, and we call those actually the bases. These are called bases. There are two pairs of base angles. So the base angles are basically what touch the bases. So there's one pair here. This is a pair of base angles. I'm not saying that those are necessarily congruent. And then there's another pair of base angles here. Okay, so two pairs of base angles. One pair touches one of the bases, the other pair touches the other set of bases. We have these things called the legs, and those are the non-parallel sides. So these two sides here, these are legs. So a lot of times what you'll end up seeing is, you got base 1, base 2, and then you've got leg 1, leg 2. Okay. This mid segment is parallel to each base. So the mid segment is basically right in the middle of the bases. It connects the midpoints of the two legs. So this we'd call the mid segment. And it is parallel to the two bases. And it connects the midpoints of the two legs. So if this is the midpoint of leg 1, then we know that these two pieces are going to be congruent. And if this is the midpoint of leg 2, then I know that these two pieces are going to be congruent. So as I just said, the mid segment connects the midpoint of the legs. And you can find the length of the mid segment For example, how about if I give these some letters? How about I'll call this AB? I can find the length of AB basically by taking the average of the two bases. So what I mean by that is length AB is equal to the average. So I take base 1 plus base 2. And the way that we average things is we add them up and divide by how many there are. So there are 2 of them. Or in other words, that's 1/2. So you might see it like this too. 1/2. And instead of writing base 1 and base 2, I'll just call it B1 plus B2. So that's another way that you could see it. This is actually part of the formula for finding the area of a trapezoid. And the area of the trapezoid becomes really, really, really important when you get to calculus. All right, let's see what we've done here. So draw a trapezoid below. Label the legs. We did that. Oh, the base angles and the mid-segment. We labeled the mid-segment. Okay, so the base angles. How can we do this? So one pair of base angles. How can we do this? Oh, I have an idea. Let's just go. We'll go C, D, E, and F. And how about if we say that angle D and angle E are a pair of base angles? And then also angle C and angle F are a pair of base angles. That way we don't make our diagram too noisy with too many things on it. So an isosceles trapezoid basically is very, very similar to just a regular trapezoid. There's a couple things that are different. One of them is that the legs, think of like an isosceles triangle. In an isosceles triangle, you had 2 of the legs of a triangle that were congruent. Well, here in a trapezoid, if we do an isosceles trapezoid, the 2 legs will be congruent. And just like an isosceles triangle, when legs were congruent, so were the base angles. So the base angles are also congruent, which then makes the diagonals congruent. So we'll draw an isosceles trapezoid below. Now, this one I'm going to try and make look like my legs are congruent. So you still have the 2 parallel bases. And now I'll try and make my legs look like they're about the same. Let's see if I can do it right. That's pretty good. Let's just pretend. All right, so how about if I call this H, I, J, K. All right, well, my legs, okay, so remember, the bases are the parallel sides. My legs are the 2 sides that are not parallel to each other. Well, in an isosceles trapezoid, those are going to be congruent. How about I'll go 3 tick marks. Base angles are also going to be congruent. So the pairs of base angles, so this K would be congruent to H because that's 1 pair of base angles. And then J will be congruent to I. That's another pair of base angles. And then the only other thing are the diagonals are congruent. So I'll go ahead and draw those in. And JH. So then I can say that JH is congruent to, now how about I'll go IK. So segment or diagonal JH is congruent to segment IK. Because those are the diagonals and those are congruent. Okay, so we drew an isosceles trapezoid. We marked all the congruent segments and angles appropriately. Let's see, what else? So I guess the only difference really between a regular trapezoid and an isosceles trapezoid is the fact that you've got these congruent legs, right? So these 2 legs here are not congruent, but these are. And the other difference is the base angle. So the pairs of base angles here are not congruent, but in the isosceles trapezoid, they are. Okay, moving on. Let's do some math with this information. So we're going to show that ABCD is a trapezoid and then decide whether it's isosceles. So I'll know if it's a trapezoid if I have one pair of bases that are parallel to each other. Okay, so it's a trapezoid if I can prove that one pair of opposite sides are parallel. So first thing, I need one pair of opposite sides parallel. Well, how do I know when two lines are parallel? Their slopes are the same, right? Okay, well, let's look. So let's start with the slope of BC. And since it's already graphed, I'm just going to count. So I go down 1 and over 3. So that's a slope of negative 1/3. Okay, and then I would think that it would be, potentially parallel to AD. So let's see. The slope of segment AD, go down 1, 2, and over 1, 2, 3, 4, 5, 6. Well, isn't that the same as negative 1/3? So it looks like these two are going to be parallel. Let's just double check the other two. These don't look parallel to me, but let's go ahead and prove it. So we'll also find the slope of segment AB. So my rise is 1, 2, 3, 4 over 2. All right, so let's see, that's a slope of 2. And then going from D to C, well, that does not look like it's going to be parallel because the slope's going to even be different, right? This one had a positive slope. This one's going to have a negative slope. 1, 2, 3, 4, 5, backwards 1. So what I say, up 5, backwards 1, or in other words, it's got a negative slope, negative 5. These two are not parallel. So I've got one pair of opposite sides parallel, therefore I know it's a trapezoid. I'm going to abbreviate. Now if I had two pairs of opposite sides being parallel, then I would have just had a parallelogram. Notice a trapezoid is not a parallelogram, but it is a type of quadrilateral. Okay, so that's part of it. I proved it was a trapezoid. Now we have to decide whether it's isosceles. All right, well, in order for it to be isosceles, the two legs would have to be congruent, right? So the next thing I'm going to do it over here because I think I'm out of room. Let's test to see if the legs are equal lengths. Okay, well, let's see. One of my legs is AB, and the length of AB can be found using the distance formula. Why don't I make this one x1, y1, and this one x2, y2? So I do the change in the x's, so 0 minus negative 2, square that, plus, and then the change in the y's, so 3 minus negative 1, and square that. All right, let's see what we get here. Minus a negative is really a positive, so that's 2 squared, plus, and then same thing here, that's going to be 4 squared. 4 plus 16, or the square root of 20. Now the square root of 20 actually breaks down. That's really the square root of 4 times the square root of 5. So I'm getting 2 root 5. Okay, now let's do the other leg. So the other leg is, how about I'll go DC. So same thing, you know, why don't I call this x1, y1, and this one x2, y2. Take the difference in the x's, so that's 3 minus 4, and square that. And then 2 minus negative 3, and square that. So I get negative 1 squared plus, and then this is really 5 squared, right? So that's 1 plus 25, or the square root of 26, and that can't be simplified. So whether you want to compare them here, or you want to compare these guys, either way they're not the same, right? So it's not isosceles because the legs are not congruent. So 2 parts to this. We answered both questions, right? Show that it's a trapezoid. We did. We had 1 pair of opposite sides. Oh, what happened? It's a trapezoid since only 1 pair of opposite sides. I forgot to put R parallel. Good thing I went back over my answer. And then we also had to decide whether it was isosceles, and we know it's not because the legs are not congruent. Okay, now we're given the fact that ABCD is an isosceles trapezoid. That's why these 2 legs are shown to be congruent. We also know it's a trapezoid because we got 1 pair of opposite sides. Those are our bases. They're parallel. We know that the measure of angle A is 42 degrees. Now we have to find the rest of the angle measures. Well, if it's an isosceles trapezoid, I know that this angle is going to be congruent to this angle. So right away, I know that the measure of angle D is equal to 42 degrees. Okay, so that's one of my answers. Now, because I have 2 opposite sides here that are parallel, think of these like your parallel lines. And then think of these legs as your transversal. So what do you know about this angle here and this angle right here? That's right. These 2 angles are consecutive interior angles, and their sum is 180 degrees, or they're supplementary, right? So we know that the measure of angle C plus 42 degrees is going to equal 180, or solving for the measure of angle C, I probably shouldn't have a degree symbol there, but that's okay. Measure of angle C will end up being 138 degrees. Okay, and then I know that measure of angle C is a base angle that is congruent to the other base angle that's adjacent to base BC, right? Because this is an isosceles trapezoid. So therefore, the measure of angle B will also be 138 degrees. All right, moving on. Example 3. In the diagram, segment MN is the mid-segment of trapezoid PQRS. Find the length of MN. Well, the way that we find the length of MN, as we wrote in our notes back here, is it's basically the average of the 2 bases, right? Take the 2 bases and divide by 2. So I'm going to take my 2 bases, the length of those, 13.5 and 18.9, and I'm going to divide by 2. It's that simple. That's just how you find the mid-segment, because it is right in the middle of these 2 bases, so it's the average of those 2. Oops. Okay. Oops, and I get 16.2. Let's see, I have inches here for my unit, so it's 16.2 inches. Okay, the next and final quadrilateral that we're going to talk about in this chapter is a kite. And a kite, well, maybe you've all seen a kite being flown. But a kite basically it's another type of quadrilateral with some special properties. So let's go over those. Now, they're all listed on page 401. So if you wanted to pause the video, go check out page 401, see if you can fill in these blanks, and then come back. All right, so let's go ahead and let's figure out some things about kites. So first of all, a kite has two pairs of consecutive congruent sides. Consecutive, remember those like are adjacent to each other, consecutive, congruent sides. Okay, so what do I mean by that? Well, I'm going to come down here. I'm going to draw a kite kind of on its side. Let's see. Let's try and make those look congruent. So there's one pair of consecutive congruent sides. And then the other ones something like that. Well, that looks really terrible, but this is why we mark things up. So here's one pair of consecutive congruent sides. Right, those two touch each other and they are congruent. And then there's another pair of consecutive congruent sides, these two. Now, opposite sides here are not congruent. So see these opposite sides? Not congruent. The diagonals, if you draw your diagonals in, and if I drew this as like a perfect kite, which I did not do, the diagonals have a special relationship. I don't think it's going to come across very well on my diagram. But that's why we can just put the little symbols in there, mark it up real nice. So diagonals are perpendicular. And there is exactly one pair of opposite angles that are congruent. Exactly one pair of opposite angles are congruent. And those are the two angles that are between the two non-congruent sides. So this angle here and this angle here. So the angles in between the two non-congruent sides are always going to be congruent to one another. All right, so we drew it, we marked the congruent sides, angles, and perpendicular lines. Perfect. All right, let's do example 5 then. So we're going to find the measure of angle C in the kite shown. Well, the thing about the measure of angle C is that it's going to be exactly the same as the measure of angle A. See how it's in between the two sides that are not congruent? Okay, so maybe I call the measure of angle C X for now. Then the measure of angle A, I'll also make that X. Now this is a quadrilateral, so what do you know about all the angles in a quadrilateral? What is their sum? Any quadrilateral, the sum of the angles is 360 degrees. So I know that 80 plus 50 and then plus my two x's is going to equal 360 degrees. 80 and 50 is 130. So I'll subtract 130 from both sides. So 2x has to equal 230. So x is equal to 115 degrees. So we know that the measure of angle C is equal to 115 degrees. Pretty simple. Once you know these properties, it's actually super easy. And the goal is to learn all these different properties for every single quadrilateral in this chapter. All right, last example. We're going to identify the type of quadrilateral. All right. So looking at A, I see that I have two pairs of consecutive sides that are congruent. Okay, so, well, that was a kite, right? We just learned that. So this is a kite. There are two pairs of consecutive congruent sides. Okay, moving on to B. Let's see here. I've got one pair of parallel sides, and that's really all I need to know. Now, I think that these diagonals right here, what it's telling me is, if I added these two together, this entire diagonal VX would be 144. This diagonal right here would be 137. So that allows me to conclude, because the diagonals are not congruent, that this is not an isosceles trapezoid. All I've got is a regular trapezoid because I got one pair of parallel sides. So this is a trapezoid because I have one pair of parallel sides. So again, it's not isosceles because my diagonals are not congruent. If I had congruent diagonals, then I could conclude that this would be an isosceles trapezoid. All right, let's see what I got here. So I've got one pair of opposite sides that are congruent. I also have one diagonal that's being bisected. Let's see. So let's write that down. So I've got one bisected diagonal and one pair of opposite sides that are congruent. Well, it kind of makes me want to say that this is a parallelogram, because one pair of opposite sides are congruent and one diagonal is bisected. Well, in order for me to guarantee that this is a parallelogram, both diagonals have to be bisected, or both pairs of opposite sides have to be congruent. I don't have that information. This is all the information I have. So I don't really have enough information to classify this as a certain type of quadrilateral. I just know that this is a quadrilateral. Okay? So it's a quadrilateral. And there's not enough info to classify it any further.